Hey there, students. I'm choosing to do for you now from Lucky Homework number 13, Lucky Problem number 13, which is a problem for linear correlation between two variables. And in this problem, it says that police sometimes measure shoe prints at crime scenes so that they can learn something about criminals. Listed below are shoe print lengths, foot lengths, and heights of males. Construct a scatter plot, which is what these options are here for the first part of the problem. Find the value of the linear correlation coefficient R and the p-value of R. Determine whether there is sufficient evidence to support a claim of linear correlation between the two variables. Well, it says between the two variables, and they've actually listed three here: shoe print, foot length, and heights. So we have to see which two variables are they talking about. But then it says, based on these results, does it appear that police can use a shoe print length to estimate the height of a male? So those are the two they're talking about, the shoe print length and the height. So the foot length is not in the claim that you're testing. If you look at these choices for scatter plots, they have shoe print on the x-axis and height on the y-axis, so those also don't use foot length. So even though they gave foot lengths, we're not actually going to use the foot length data, just the shoe print data and the height. Okay, so having read the problem, we're supposed to do this to a significance level of alpha equaling 1%. For the first part, it says construct a scatter plot and choose the correct one of these below. So we'll want to do that in StatCrunch, and we'll want to use the 5 data pairs of shoe and height values here. So I'm going to open these data values in StatCrunch. And of course, what we'll see is that we have 3 different columns here because there is this foot length column that we don't need, but that's okay, we'll just ignore it. So to make a scatter plot, that's a kind of a graph. So we would go over to Graph and choose Scatterplot, kind of in the middle of our graph choice list there. So I'm clicking on Scatterplot, and the x-axis is the horizontal one, should be the shoe print, the y will be the height, and we will ignore foot length. And then I'm just going to go compute. So it gives me a graph, and I want to see which of these this looks like. You can try to adjust the shape a little bit. Also, they cut this off kind of at the top where these graphs go higher. But usually from this, you can recognize the pattern that matches one of these because they're not too similar. In this case, I have the bottom left corner and then a lump in the right corner. That's this matching here. None of the others seem to have that pattern except D. So then they want us to get the linear correlation coefficient R. So that is not a graphing, that's a calculating kind of an issue. So I'm going to go back to Stat. And then this is a linear correlation problem, and the tool we use for that is regression, because linear regression is the idea of making a linear model out of data, and so that's what we're doing. Anyway, that's under the regression title, and I go simple linear. So I go under Stat, Regression, Simple Linear. Again, I choose the foot for the footprint for the x and the height for the y. Sorry, the shoe print for the x and the height for y, ignoring the foot. And they talk about hypothesis tests, and they talk about the intercept and the slope. So for this kind of a problem, we can ignore that. If I just go compute with the defaults after I put those in, we're probably good. And you do get a little bit more data than we're used to getting at this point, so let me show that so we can see how we use which of this data to answer the problem. All right, so the linear coefficient R, so that's listed right here. R is the correlation coefficient, and that's this number here. That's on our list of stuff here. And so they want that to 3 decimals, so I would grab that to 3 decimals. Looks like I have to round up the 0 on the end to a 1. And then they want the hypothesis, the null and the alternative hypothesis. So the claim is that there's a linear correlation, and this little row symbol is the linear correlation for the population. For the sample, it's an R. For the population, it's this little, looks like a P. And the null hypothesis will always be that it's equal to 0. That would mean that there's no linear correlation because the measured linear correlation is equal to nothing. And then the alternate is that the row is not equal to 0 because it could be something closer to a 1 or a -1. In both cases, that would mean there is a linear correlation. So we're just going to go with always not equal to 0 as our alternate for our hypothesis test. Then they want the test statistic. So that means based on our data, what was the t-value in the test statistic? So we've got different things here. It has a t-stat for intercept, t-stat for slope, and an f-stat. So just to cut to the quick, what we want, the r value is like the slope of the line. Positive is uphill, negative is downhill. So we want the t-stat, and it does clue us in because there's a t here. We want the t-stat for the slope, not for the intercept, but for the slope. That's what they're asking for. It says round to 2 decimal places, so I'm just going to grab that. I don't have to adjust that. So again, for the t statistic, for a linear correlation hypothesis test, you want to get the t-stat from the slope in the StatCrunch calculator. Then they want the p-value. That will also be for the slope. If you notice, there's a p-value down here, and those match. So actually, both of those are the same. You just do not want the p-value for the intercept. You want everything for the slope. And they want that to, what, 3 decimal places? Yeah, so I have to round my 1 up to a 2. I put that in. And then let's draw our conclusion. We do have a p-value of about 3%. The significance level given in the problem was 1%. If the p is low, the null must go. The p is not low, so it is greater than the significance level, so there is not sufficient evidence to support the claim that there's a linear correlation. And in this case, the linear correlation would be used to try to predict the height of a perpetrator based on shoe size, but since there doesn't seem to be evidence that there is a correlation, then I would say, based on the results, does it appear police can use the shoe print to estimate the height of a male? That no, because it is not appear to be correlated. I'll just use A in this one. So there you go. Some parts to this, definitely a little bit more data than we would like out of StatCrunch. We have to learn how to pick the data parts from it that we want. But hopefully this helps for lucky number 13. Keep up the hard work, and come see me in office hours if you need help. Best of luck.